The story of artificial intelligence did not begin with silicon chips. Well, it began with a question. It is a question as old as our own consciousness. Can a machine think? For centuries, this idea was the stuff of myths and speculative fiction. It lived in stories of clay golems, mechanical men. But in the last century, this ancient dream began to take physical form. The journey from abstract thought to tangible reality happened in distinct transformative eras, one idea leading to the next. This essay traces that path, one step at a time. From thinkers and philosophers to builders and researchers, it reflects our quest to decode the nature of intelligence. Each era built upon the last, like sediment forming a new landscape. The timeline is surprisingly compact, most breakthroughs within a single lifetime, and it began with people who saw thought as computation. Long before the first electronic computer hummed to life, the seed of AI was planted in mathematics and philosophy. Thinkers sought rules of reasoning. They tried to formalize thought itself. Systems of logic could capture how we reason. The radical idea: if reasoning follows rules, a machine could follow them too. Thought made mechanical in principle. Boole and Frege made it concrete with symbolic logic. Complex ideas reduced to true or false, a blueprint for representing and manipulating information. Babbage and Lovelace imagined a programmable engine, not just numbers, any symbol, even musical notes. Visions that linked abstract logic to physical machines. Quiet conception gathered the essential components: logic, mathematics, computation, the intellectual infrastructure. How could a machine think? The answer: with logic. The 1950s marked the true birth of AI as a formal field. Electronic computers finally put theories to the test. Alan Turing reframed the debate with the imitation game. If a machine converses indistinguishably, call it intelligent. In 1956, a workshop coined the name artificial intelligence. Founders believed every feature of intelligence could be precisely described. They brainstormed, debated, and laid out a roadmap. The event gave a name, an identity, and a purpose. Early systems solved algebra, proved theorems, and played checkers. Good old-fashioned AI, explicit rules and logical deduction. Many thought human-level intelligence was near with scale. Predictions were bold, timelines optimistic. Funding surged, ambitions soared. Simple programs, great hopes. The dawn felt like an imminent breakthrough. After the burst of enthusiasm, progress slowed. Rule-based systems struggled beyond toy problems. Real-world messiness exposed brittle methods. Combinatorial explosion overwhelmed computers. Slightly harder tasks brought systems to a halt. The first AI winter set in. Grand promises hadn't materialized. Language remained far from solved. A critique chilled neural network funding for years. Skepticism rose. Money dried up. Many labs downsized or closed. General intelligence moved aside for practicality. Expert systems found a niche in narrow domains. From diagnosing blood infections to configuring computers, they saved companies millions. AI could excel at specific, well-defined tasks. As winter thawed, a different approach took hold. Instead of hand-coding rules, what if machines learned from data? That is the core of machine learning. Intelligence became inference and pattern recognition. Backpropagation enabled multi-layer networks. They showed networks could learn complex patterns. Show, guess, adjust, learn by feedback. Repeated millions of times, skill emerges. Recognizing handwritten digits became tractable. New algorithms expanded the toolkit. PCs and the internet created a data fire hose. Text, images, and user data fueled learning. More data, better models. Practical successes multiplied. ML became core AI, a new engine, data. The new millennium united massive datasets and compute. GPUs excelled at the math of large neural nets. Networks grew deeper. Deep learning arrived. Layers learned hierarchical representations, from edges and colors to ears, whiskers, and faces. Systems could see, hear, and read with striking accuracy. In 2012, a watershed moment, AlexNet stunned the field by a dramatic margin. Overnight, priorities shifted. Labs and companies poured in resources. Speech recognition powered assistants like Siri and Alexa. Translation quality leapt forward. In 2016, AlphaGo conquered a grand challenge. With data and compute, systems reached superhuman levels. Scale transformed what AI could do. We are now living in the era of ubiquitous AI. Deep learning breakthroughs have been productized, integrated into daily life. Not self-aware minds, but powerful, specialized tools. They recommend movies, tag friends, guide navigation, aid doctors. Large language models write, code, and answer complex questions. AI accelerates discovery from proteins to climate. It automates tasks and optimizes supply chains. It opens new creative frontiers. But challenges of bias, displacement, and privacy demand debate. Power requires responsibility. Models scale. Capabilities expand from perception to generation and reasoning. Expect AI as a partner at school, in labs, and at work. Today we stand at a unique inflection point with unprecedented tools. The next chapter will be written by the choices we make now.